Okay, we're going to be doing lesson 5.4, which is called compound inequality. And so far we've been dealing with one-step and multi-step inequalities. So what we're going to do today is solve what's called compound inequality, which just means it's going to contain the words and the word or in it. All right, so now we're going to go back to English class here, and we're going to solve what's called a compound sentence. Okay, a compound sentence. And a compound sentence, if you recall from English class, is just a sentence that contains the word and or. Okay? All right, and I'm actually going to give you an example here of a sentence, and then we'll kind of take a look at what that actually means. So a sentence that contains the word and or would be something like, Sarah, so this is your example, Sarah went to dinner and the movies. Okay, so if I'm looking at that sentence right there, okay, the word and implies that she does this and this. So in other words, both parts are true. So on an and statement, okay, both happen or both are true. Okay, now if I take the word and out and I put the word or in its place, now we completely change the meaning here. So Sarah went to dinner or a movie, which implies that she's only doing one part. So if she's only going to do one on an or, that just means one is true. So she's going to do one or the other. Okay? All right, so let's take kind of a look at a real life example here of what a compound inequality might look like. And it says to ride the vortex at Kings Island, you must be at least 52 inches tall and your height cannot exceed 72 inches. Write two inequalities to represent this situation. So now if I'm writing my first inequality here and it says that I must be at least 52 inches tall, okay, so that means x, which will be my height, and I'll put that up here, x equals height. Okay, so I have the x, if I'm at least 52 inches tall, that means the smallest number I can be is 52 and still get to ride. All right, and if I look here, you see how it says the word and, so I'm going to write the word and here in the middle, and my height cannot exceed, which means I can't go over 72. Again, remember that alligator mouth? Remember this alligator mouth eats the bigger number. Okay? So now, when it says write one inequality represents the situation, when you have an and, you can actually kind of scrunch it all together. And so when I mean scrunch it together, you're actually going to take your lowest number, so 52, and if I think about this, I should probably back up here. If I rewrite this as 52, flip it like that pancake we talked about in class, so if I take it and flip it over and I get 52 is less than or equal to x, when I write it over here, 52 is less than or equal to x, and I can just share the x. I don't actually have to write this x again. I can just share it since it's already there and say less than 72. Okay? Now, this is a way that we write an and statement, and it's just condensed into one thing. So you either have the option of writing it out, two numbers with the word and in there, or scrunch it all together and write it as what we call compound inequality. Okay? So now, a compound inequality is where we're going to have two inequalities. So two inequalities. So I have two, pen here, two or more inequalities that are connected by the words and or the word or. So and or there. Okay? So now I have kind of two important points here to kind of look at. For the word and, okay, so for the word and, That's when we're talking in terms of graph, and we're going to look at here in a second, where the graphs overlap. Okay? And the word or will be when I just graph everything and I'm not too worried about what's going on. I'm just going to graph everything. Okay? All right, so just kind of review here a little bit with you. We have two or more inequalities that are connected by the words and and or. If I have an and statement, I'm going to find out where do those graphs overlap. If I have an or statement, I'm just going to graph everything. Okay? So now we're going to look at example 1 here, and you notice in example 1, this is an and remember how we scrunched it together a little bit earlier? This is also going to be an and statement as well. So just keep in mind that this is going to be an and. Okay, so I'm going to go ahead and zoom in here on 1A, and we're going to solve. Now you're going to solve both inequalities. So I'm going to start by adding the 3 over to the other side. So that cancels. So y is greater than or equal to negative 8. Add the 3 over here on this one. And I'm going to get y is less than or equal to negative 5. Okay, so now what I'm going to do is I'm going to graph it, and I'm going to graph them both on the same line here. Okay, so on this one I'm going to do, let's see, negative 8, 7, 6, negative 5. Okay, and if I look on the first one, I've got a closed circle at negative 8, and I'm going to be heading in this direction. Okay, I'm going to change the blue here and graph the second one. I've got a closed circle on negative 5, and I'm going to be going in this direction. Okay, so the question is, where are they overlapping? Well, if I look here, they're going to overlap between these two. So now my final graph should just look at where they overlap. So I'm going to overlap between negative 8 and negative 5, and I've got a closed circle here. I've got a closed circle here, and where do they overlap? They're overlapping everywhere in the middle. So that's what my final graph will look like. You can think of this graph as just like a working graph. Okay? Now, you do need to write your final answer, and your final answer you've actually already got back here. But remember, we're going to go ahead and kind of scrunch it together. All right? So if I'm thinking about this, you're always going to start with your low number and go up to your high number. Okay? So I'm going to have negative 8 less than or equal, my variable is y, which is less than or equal to negative 5. So again, I have my low number to my high number, low number to high number, and I'm just using the signs that are here. Now keep in mind up here that this is the same thing as I'd say negative 8 is less than or equal to y. These right here say the same thing, so I'm just flipping it like a pancake again. And you can see that that's represented right here. All right, and then let's not forget our set builder notation. Okay. All right, example 1b. Okay, again, we talked about that this is indeed an and statement. All right, so one way to think about it is just to go ahead and write it out as two separate inequalities. So I've got 6 is less than and equal to r plus 7, and then r plus 7 is less than 10. Okay, I'm going to solve my inequalities. Again, remember there is an and here in the middle. Probably should write that. So subtract the 7 off. So negative 1 is less than r. Over here I subtract the 7, so r is less than 3. Okay. So again, if I'm thinking about graphing on a number line, I do want to go ahead and put my variable out front for my graph. So I'm graphing here at negative 1, 0, 1, 2, 3. Okay. Now, since I got this in red, I'll keep it in red. I've got a closed circle on negative 1, and I'm going off in this direction. And my other one here, I've got an open circle at 3 headed in this direction. Okay. All right, so my final graph again is where are they overlapping at? They'll be overlapping between negative 1, closed circle, and 3, open circle, and shade in between. Okay? Now, again, you've got to write your final answer, and when I come up here, I'm going to go ahead and look at where my variable's kind of already in the middle. If you look at that, they're already sharing it, so you're just going to kind of compress this together right here. All right? And when you do that, your final answer will be negative 1, less than or equal to r, less than 3. Again, set builder notation. Okay, so again, just keep in mind up here that I'm basically just kind of putting those together. Also, you can look here, negative 1's my smallest number, 3's my biggest number, and you're all pretty much going to have lessons in the middle if you go from least to greatest. All right, let's go to the second example here. Okay, and now we're going to look at compound inequalities, but with the word or. Now, previously we talked about that the word or meant we graphed everything. So what I'm going to do is still solve my inequality. So I'm going to start this first one by subtracting 1 from both sides and getting a is less than 3. I'm also going to add the 1 here and get a is greater than or equal to 4. All right, so now when I graph that on a number line, I'm just graphing everything. I don't care what's really on my graph. So I'm going to have an open circle at 3, and I'm going to shade in this direction. I'm going to have a closed circle at 4, and I'm going to shade in this direction. All right, so now again, I don't care that they're not overlapping. On an OR, we just graph everything, and anything that is graphed is your answer. So I have these two things right here as my answer. Now, there's no special way to write an OR, so your final answer is just going to be a is less than 3 or a is greater than or equal to 4. Again, set builder notation. So on an OR statement, you will have an OR in between. All right, example, the second example here. Now, the nice thing about this one is x is less than or equal to 9 is already done for you, so we just need to solve the second one before we stick it on our grid. So I'm going to subtract the 2 off. So I have 4x is less than 8. I'm going to divide by 4 and get x is less than 2. All right, so again, I'm going to graph both, not caring about what it looks like. So 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got an open circle here at 2, shading this way. And up here for the 9, I've got a closed circle, and I'm shading this way. Okay, so now when I'm looking at my final answer here, my final answer is based off the graph. What's been graphed? Well, everything from the 9 over has been graphed. Even the 2 has been graphed. It got covered up by the 9 when it came through. So the only thing I really need to write is everything will be less than or equal to 9. And that does include this 2, so I don't have to write this 2. Okay? Again, set builder notation. So on an OR, we don't care what's been graphed, just that everything needs to be graphed. All right, and the last thing we're going to look at is when they ask us to write a compound inequality for the graphs. So what you need to determine first is it and or? So if it looks like it's overlapping, and this does indeed look like it's overlapping, that's going to be an and statement. And if I look over here on this one, you see how we got one going in one direction, one going the other. There's no overlappage here in the middle. So that would be an or statement. Okay? So now when I write this is that compound inequality stuff again. You're going to have -3. Again, keep that less than. Since it's an open circle right here, this is an open circle, I just have the word less than. Any variable you want, x, y, t, don't care, is less than or equal. I know it's an equal because it's closed. 3. And then again, go ahead and put your set builder notation around it. So now on the second example here, we'd already talked about it, that's an OR, and I told you on an OR statement, you don't compound it like this. You don't put it all together. You're just going to write this one and then this one and stick the word OR in between. So I'm going to have x is less than -2 or x is greater than or equal to 1. Again, compound inequalities. And I'm going to go ahead and do my set builder notation.